Good morning everyone. Today our team will be presenting on process versus thread and multi-threading models. The goal of this presentation is to help you understand the fundamental building blocks of concurrent executions in operating systems. First, let us understand the difference between processes and thread. A process is an independent program in execution. It has its own memory space, code, data and system resources. Each process runs it in a own protected environment, like separate container on your computer. Example, applications like Chrome browser, Microsoft's Word or Spotify. On the other hand, a thread is a lightweighted unit of execution that exists within a process, like processes. Threads share memory resource of the parent process. Multiple threads in a single program allow tasks to run simultaneously. For example, in a media player, one thread may render the UI, another may handle file downloads, and another may manage video playback. So, in summary, processes are like separate applications, while threads are smaller tasks within a process that work together to improve performance.
Hello everyone, myself Saktivel. In this slide, let's look at the key differences between the process and the thread. A process has its own separate address space, which means each process works independently. On the other hand, threads share the same memory within a single process, making them lighter and faster. When it comes to creation, process are heavier and take more time, while threads are lightweight and quick to start. For communication, process needs special mechanisms like interprocess communication, but threads may easily share data through shared memory. In terms of isolation, process are fully isolated, which gives more security where threads share resources with each other. Because of this, processes have high resource cost while threads are more efficient and have a lower overhead. For example, a program like MS Word or Chrome uses multiple processes while a spell check or a user interface tasks run as a thread. Processes provide isolation and security, while threads enable faster, efficient concurrency with an application.
Myself Kishore, studying at AC third year. Now we have to see about the multi-threading models in operating system. Operating system map user level threads to kernel level threads using different models, each with unique trade-offs in performance, concurrency and complexity. First one is many to one. Multiple user threads mapped to a single kernel thread, simple but limited one blocking call blocks all threads. It is used in early threading libraries. Next one is one-to-one. Each user thread maps to a kernel thread, provides true parallelism but higher overhead per thread. It is used in Windows and Linux. Last one is many-to-many. Multiple user threads map to multiple kernel threads. It is flexible and efficient but complex to implement. It is used in Solaris and modern systems. Thank you.
So coming to the choosing the right module, first we analyze the requirements of the in this here consider whether you need the true parallelism and how many threads you will create and what blocking operation you will perform. That will be come to the analyze your requirements. Coming to the understands the trades off which balance the concurrency benefits against the overhead cost. Then one-to-one offers the simplicity and performance, while many-to-one provides the flexibility. Then coming to know your platform, that modern operating systems like Linux, Windows, like that we going know that use the one-to-one model, which provides the excellent thread support out of this box. In key sites, we see that the processor provides its isolation for running multiple programs, while threads enables the efficient concurrency within a single program. Understanding its multi-threading models, which helps you to write better concurrent applications. So these are the key sites we understand from it. So let's get into the about the one-to-one and many-to-one model. Okay, so let's get into it. So coming to the types of multi-threading, we will see the three types. Here is one many-to-many model, then many-to-one model, then one-to-one model. So let's see about the first one is the many-to-many model. So in this many-to-many model, consider an example that this is like having many assistants but also multiple clerks, and let the manager decide which assistant goes to which clerk. It and also it balances the workout, or else another example we can say that in windows hours and some implementation in Solidus use this model. Then the OS which schedules user threads to the pool of the kernel threads, which gives the both efficiency and parallelism. If you are running a server or handling any thousands of web requests, the OS map user threads dynamically to available the kernel threads. So here's the diagram that we have this user thread, then the user kernel boundary, then the kernel thread A. So this is how the many to many model performs here. So coming to the many to one models, here we will see that the many to one model. Imagine that in a office you have 4 assistants, and but you give their work to the one clerk to process it. They will line up and only one can served at the time. That like this many to one process will done. Or in a real-time example, we say that in older version of Java, in Solaris OS use this model. It was simple, but it's not so efficient. If one thread is blocked for import, all others has to be wait until the first thread is has to reach. So this is how the many to one model performs. So coming to this one to one model, which performs how it means that here each assistant has their own clerk and works done in parallel. Then in a real-time example, we see that the in Windows and Linux use this model. If one thread waits for the I/O, the others can still run because they are separate kernel threads. This is why the modern apps can download a file which you type and listen to music at the same time, like opening the tabs in multiple, like that we will used to say. So this is how the many to one no sorry one to one model performs here. So that's all. Thank you.